Fire alarms and sprinkler systems. In this presentation, we're going to be looking at fire sprinkler heads, fire sprinkler pumps, wet and dry fire sprinkler systems and their wiring, supervisory fire sprinkler equipment, and supervisory equipment and how it connects to an addressable fire alarm system. All fire sprinkler systems deliver water from sprinkler heads. They're made up of a deflector, a frame, a sealing assembly, and a temperature-sensitive glass bulb that's all threaded into a standard steel or plastic water supply pipe. The temperature-sensitive glass bulb holds the sealing assembly in place. The glass bulb bursts at a specific temperature, and the glass bulb is filled with an alcohol solution that is designed to break through the glass tube wall that houses it at a specific temperature, and that temperature is easily identifiable visually by the color of the alcohol inside. Bursting of the glass bulb allows for the sealing assembly to then slide out. If we take a look at the general operation, under normal condition, we should be able to see the glass bulb present in the sprinkler head. During a heat event or a flame, the liquid bulb will burst once the heat at the ceiling reaches that predefined temperature. The plug will be pushed out by either water or air pressure, and eventually water will be released over the ignition source, but only out of that one sprinkler head that is burst. Many fire sprinkler systems require a fire pump to ensure adequate water pressure. This is often seen in systems that have multiple stories of building, like 10 stories high. How do you get the water up there? Well, you need a fire pump. And a fire pump, it consists of an electric motor and a water pump. The fire pump is extremely important. Due to this, there are many allowances made in the CEC to ensure the pump runs under any circumstance. First, the separate service at a building. During a fire event, often the power will be cut to the building. A separate service allows for the main building power to be cut without de-energizing the fire pump. A main service disconnect lockable in the on position. The fire pump must always be capable of turning on when required. Ensuring the disconnect for this load is lockable in the on position ensures it cannot be accidentally turned off and forgotten. The overcurrent for this motor is sized to carry the motor LRC indefinitely. LRC is the locked rotor current. This is the amount of current that would flow if the motor was prevented from turning. It would be humongous. Now the overcurrent is sized this large to ensure the motor pump continues to run even if drawing high current due to a failed bearing or other mechanical failure. On a standard motor application, high current events are limited. If they occur too often or are too large in magnitude, the system protection should de-energize the motor to prevent damage. In fire pump systems, the motor must run until complete destruction. The magnetic motor starter for a fire pump has no overload protection. The purpose of overload relays in motor circuits is to protect the motor winding from damage due to heat from high current. Fire pumps are intended to run until they are no longer physically capable of turning. It is more important to pump water for the sprinkler system than to de-energize the motor early and protect the stator windings. Finally, highly robust wiring method from the load side of the fire pump controller to the fire pump itself. Armored cable, mineral insulated cable, rigid metal conduit, and concrete encasement are all common methods of supplying a fire pump. The intent is to reduce the chance of supply conductor damage due to fire or mechanical impact. If we take a look at the single line diagram for a standard fire pump, we'll notice the fire pump controller ahead of the fire pump with its overcurrent and power contacts at the very bottom there. And it can be supplied power either from the main building supply service off the distribution or a separate fire pump supply service. In a larger assembly or system where we have essential loads for life safety, often there's an emergency generator on site. The emergency generator is going to supply power to not only emergency power loads, such as emergency lights and maybe life safety equipment or equipment in a hospital, elevators, things like that, through its transfer switch, but it will also supply power to a transfer switch for a fire pump if it is on site. The separate supply service is covered under 32304 and 61021A. The overcurrent size for locked rotor indefinitely and lockable requirement is found in 32306. The circuit breaker for the fire pump is permitted to be connected upstream or bypass the main emergency generator circuit breaker. Upstream means it's on the supply side, and the significance of having this connection of the fire pump circuit breaker on the upstream side of the main emergency gen circuit breaker is that if there were to be a short circuit in this conductor right here during an emergency event when the emergency gen was operating, this breaker alone would trip. The emergency generator would still be capable of supplying power for the fire pump because the fire pump circuit breaker is upstream or before this breaker. And so the redundancy is increased. There's a higher chance that the fire pump will continue operating even if there was a problem with some of the distribution of power to emergency power loads. Finally, 32310 is a requirement for no overload protection in the fire pump controller. And, I guess this is finally, each fire pump must have its own separate transfer switch, 32308 Several 2. If we had 5 fire pumps, each fire pump would have its own individual transfer switch, as opposed to having one large transfer switch for all of them. That way, if one transfer switch were to fail, the remaining fire pumps would still be able to operate. Redundancy is the name of the game when it comes to fire sprinkler pumps. The fire sprinkler pump might be used in a wet or a dry system. Let's take a look at how a wet system functions. A wet sprinkler system requires all of the piping to have water in it at all times. The sprinkler head sealing assembly and the little glass tube are the only thing that keep the water from coming out. During a fire event, whichever sprinkler head is nearest or it has the temperature applied to it will burst, and sometimes it's one and sometimes it's all of them in the room. It kind of depends on the heat of that source. The plug assembly is then pushed out after the capsule bursts and water immediately comes out of that local sprinkler head. It's important to understand that the water will not be crisp, clean, beautiful blue water like what we see in the movies. Instead, the water that sits in these pipes that are typically metal will be a little bit corroding because it's standing water and it's not moving. So it's going to be black, sludgy, brown, stinky, disgusting, muddy swamp water that will be released in that local environment until eventually all of that water, sludgy stuff gets pushed out, and then you get some of the nicer, cleaner water. It is not something you want to take a shower in. It's important to understand that throughout this procedure, the fire alarm panel did not control when the sprinkler system activated. The fire alarm panel is connected to the sprinkler system with a flow switch. When the flow is activated, the contact closes inside the unit, sending a signal to the fire alarm panel. So we can see here, set of contacts in there, no flow and water flow, and we'll see that it's connected much the same as how a standard pull station would be connected back to a fire alarm panel. This is what a standard fire sprinkler flow switch looks like. Usually there is a time delay mechanism in it to avoid for a false alarm. This flap down here is inside the pipe in the path of the water. It is very flexible and plastic, which means when water pushes against it, it will move and set off a trigger or contact inside the mechanism up here. If there was a bit of a pressure wave in the water, we would not want the fire alarm panel to think that there was flow of water and go into alarm. Instead, there's a time delay feature, which an individual can then set, and the setting is usually in anywhere from like 5 to 15 seconds. So the flap has to be pushed by flow of water for at least 5 to 15 seconds before the contacts close, in which case the signal is then transmitted to the fire alarm panel. Let's see how that's wired to a conventional system. So here we're dealing with a Class B conventional system, and we've got the sprinkler system flow switch down at the very bottom. You'll notice its connection is almost identical to a standard pull station, however it's terminated onto its own separate IDC loop. When the sprinkler head is activated, water starts flowing, and after that 5 to 15 second time delay, the contact should close, at which time we should see an increase in current flowing through this section of my IDC loop, which the fire alarm panel will recognize as an alarm and then flip the notification terminal's polarity to energize all of the NAC devices. Dry sprinkler systems operate in a different way, and the reason you would want to use a dry sprinkler system is in locations where it is cold. Sometimes sprinkler heads are required to be outside the building envelope. In those situations, standing water in sub-zero temperatures could cause the water to freeze and burst the pipe. Other times, we need to have pipes that go through environments that are extremely cold, like large walk-in or freezer warehouses where food distribution takes place. Again, these systems need to be dry because standing water will freeze and break the pipes. In order to operate a dry sprinkler system, we need an air compressor. The air compressor's role is to pressurize this portion of the piping with compressed air. It also has a flapper valve. A flapper valve is paramount in this operation. The valve which operates on difference of pressure is a flapper valve. When pressure is equal on both sides of it, the valve remains closed. If pressure drops on the outlet side, that'd be up here, then the flapper opens due to the water pressure down below. The air compressor keeps the sprinkler system pipes charged with pressurized air, and the pressurized air keeps the flapper valve shut. It would be expected that the air compressor runs periodically throughout its lifetime, and that's because there will be small air leaks and air will simply slowly leak out of different areas of the pipe over time. So it's expected that this will kick on every so often. During a fire event, the sprinkler head used is exactly the same as a wet sprinkler. It's going to have an alcohol capsule and a plug assembly. When heat is applied and it reaches that temperature, the glass bulb will burst. The plug will be pushed out, but this time with air pressure. Now, the air pressure will drop in the pipes, and depending on the size and the capacity and the design of the system, the air compressor might be controlled in such a way that it has power cut off to it, in which case the pressure drops much quicker. Other systems, the air compressor can just simply not keep up with the pressure drop. In either situation, what will happen is that this dry section, pressure-wise, will drop, and that will cause the flapper valve to then open. Water will then fill the sprinkler pipe and flood through to the open head where it will be released on the fire. Again, it's important to understand that the fire alarm panel does not control when the sprinkler system activates. The fire alarm panel is connected to the sprinkler system with a valve switch. When the valve opens, the contact inside will close, sending a signal to the fire alarm panel. So there we can see the flapper valve switch mounted on the flapper valve, and it all comes as a designed unit for use with fire alarm systems. And we have a contact in there, open, closed, pretty basic. Let's see how it connects into a dry conventional system. So there's our conventional Class B, and again we've got our sprinkler system flapper valve down at the very bottom there, and during normal operation those contacts should be open, and there's a, same, it's conventional, so there's an end-of-line resistor and current flowing through the whole thing. A little bit of current, supervisory current, same as the previous system we looked at. Sprinkler head is activated, the air pressure drops, the water starts flowing, and we would expect for the contact to then actuate when the valve fully opens. That would cause an increase in current through our IDC loop, of which this fire alarm panel will recognize as an alarm, and it will notify or make all of the NAC devices energize by a flipping of polarity. Now, it's important to understand that people are generally forgetful, stupid, malicious, and greedy. Because of this, fire alarm systems are designed to ensure that nobody can intentionally or unintentionally disable a fire sprinkler system. Manual hand-operated valves are required in the sprinkler system supply piping according to Plumbing and National Building Code standards. This helps to facilitate maintenance and replacement of equipment in the water system. If mistakenly left in the closed position after a maintenance task, the sprinkler system would remain inoperable. Electrical fire alarm equipment installed to monitor fire sprinkler systems are called supervisory devices. If a problem is detected, they will initiate a supervisory condition at the fire alarm panel. A supervisory condition means there is a problem with the fire sprinkler system, and this condition is investigated much faster than a standard trouble condition would be. Supervisory switches are located on any type of manually operated valve, be it a linear valve like we see in the far right, or a rotating valve like the one we see in the middle, and sometimes they are manufactured just to monitor pressures of water or air pressure if it's a dry system. If we take a look at a hand-operated valve, a standard form is one with a stem that moves in and out on threads as the wheel is rotated. The role of this device shown here is to sense any movement of the valve by manual operation. If we take a look at the stem of this valve, we'll notice that it will have a groove ground into it by the manufacturer. When the valve is operated, this stem will move in a linear fashion, up and down. And because we have this pendulum sort of object rod here mounted in the middle of the valve right here, this rod will then move when the wheel is rotated because the stem will move in and out. Once it does, it'll cause this to move, and that will then trigger a set of contacts to operate, sending a signal to the fire alarm panel. This will initiate a supervisory condition, not an alarm. If we look at locations for supervisory pressure switches, they can be varied and numerous. Most sprinkler systems will have multiple pressure switches in strategic locations to monitor both water and air pressure of the system. If pressure drops below design levels, electrical contacts will either open or close depending on the system. High pressure is usually open, and then loss of pressure is usually a connection or closing of a set of contacts. Again, this will initiate a supervisory condition at the fire alarm panel. But wait, what about malicious and greedy? Oh, that guy looks malicious and greedy. If a building owner is determined to commit insurance fraud, one of the ways is to burn the building down. With minimal electrical knowledge, they could simply open each device cover and disconnect or rewire the wiring prior to tampering with the valve. All sprinkler system supervisory devices will have a built-in tamper switch. The switch is activated as soon as the cover is removed, and the cover needs to be removed in order to access the electrical connections inside. It's a spring-loaded micro switch which is connected in with the wiring. When a tamper switch is triggered, it initiates a supervisory condition at the fire alarm panel. So here we can see an example of the entire system to a Class B conventional. This loop here is the fire sprinkler loop, where we have a fire sprinkler flapper valve. That would be for a dry system, and it has a tamper switch in it. Not every flapper valve will have a tamper switch, but some will, so we're going to include it in this diagram. Down here, these are all supervisory devices. These are all pressure switches, and maybe they're connected to valves to see if the valve has been opened. Each of those will have a tamper switch. Now we'll notice that each of these are then wired out to their own independent IDC loop, and this one, its own independent IDC loop. The manufacturer will indicate which IDC loop I should terminate things onto in order for it to distinguish between a flapper valve, which would send it into alarm, and a supervisory device, which would send it into supervisory. So, to confirm, opening any tamper switch will initiate a supervisory condition at a fire alarm panel. The flapper valve operation should initiate an alarm condition at the fire alarm panel. And loss of pressure or movement of the shutoff valve should initiate a supervisory condition at the fire alarm panel. As I said before, some fire alarm panels that are conventional will have a way to program them. Others will actually require a different size of resistor, and that different size of resistor will then cause a different value of current to flow, and the system will recognize that as a supervisory loop. There's lots of different ways that it can be done. Fire sprinkler system devices are conventional manufactured only. So that means addressable fire alarm systems require the monitor addressable module to connect that equipment back to the SLC equipment or circuit. Now remember, a monitor addressable module is for use with detecting type devices and to connect those conventional devices back to an addressable system. Now there's a couple of different variations on this. I'm simply going to show you two very common types out in the field. The first one we're going to call Company A fire alarm. Maybe that's Edwards or Kidd or I don't know. There's like half a dozen different brands out there. But Fire Alarm Company A produces an addressable monitor module, and in this one, they require only two connections. These two connections will be monitored for any sort of wire breaks, and there's an end-of-line resistor, and built into each of our components is usually the actuating device and the tamper. And so, just like all other conventional wiring, there's going to be supervisory current, and if the tamper switch is opened, this particular module will be programmed to recognize that this is a supervisory condition because of what I have connected. So it's something that has to be programmed into it. If instead the contact closes in this being a flow switch, that should initiate an alarm, and that's because of the current rising in this conventional branch. This is, let's say, fire alarm manufacturer B, and it's the same application, but the manufacturer requires that we have a separate connection for our flow switch than for our tamper switch, and each of those then having its own independent end-of-line resistor. This is simply to show you that there are different ways it can be done, and it's not going to be assumed that you have to put one or the other in. When you are given the equipment on site and you look at the prints, you'll see one of these two different variations provided, and you'll then look at the manufacturer's wiring instructions to determine exactly how the wiring connections need to take place and what size the end-of-line resistor will need to be.